everyone, welcome back to Diksha Karnataka YouTube channel, and today I am going to discuss the last of the chapter electric charges and fields, and today's topic is JEE PYQs. I am going to solve 20 plus PYQs from your previous year JEE exam. Okay, it will be mostly comprises of 2025, 2024 and some of 2023. Unfortunately, in this lecture the years are not mentioned. I will try to add the years in our next chapters PYQ series. So now if you are someone who is preparing for JEE as well as KCET or mainly JEE also, you can check this questions. They are all very important, and as you know that JEE questions levels are slightly difficult, more trickier compared to that of KCET exam. But KCET higher difficulty level questions are generally many of the times are exactly copied from JEE exams, and they just change the data, they just change the language, but the concept of the question remains the same. So without much delay, let us check the result of our KCET 2025. So if you see that Prajwal, Kiran, Diksha, Soumik Sir, Sachin, they all studied from us through YouTube, only through YouTube, and they have achieved a brilliant result. Not only them, there are a lot of other students within 5,000 to 6,000 rank. As you can see, their result is here, and if you are studying seriously from us, then your picture will be here next year, right? I don't see too many of you are too much enthusiastic. Not of all of you are answering the homework questions that I am posting after every session. Right, so you have to answer those questions and also check the PYQ series, and whatever doubts you might have, that also you have to ask me if you have any doubt. Okay, that I am not seeing too many students are doing it, right? So let's start with the session. First question, first 2 or 3 questions are slightly easier. Let's see. A small uncharged conducting sphere is placed in contact with an identical sphere but having 4 into 10 to the power of minus 8 coulomb charge. So we have 2 spheres. Basically, what is the meaning of that? We have 2 spheres, okay, identical spheres, say A and B. Even though my drawing does not make them identical, let me try to draw as identical as possible. Okay, now perfect. Now what it is says that first is uncharged, so it has charge 0. Second one, on the other hand, is not 0, it has a charge. So this is QA, initially this is QB, and it has a charge of 4 into 10 to the power of minus 8 coulomb. Now I will take a little slow. I'll try to explain the process. I know many of you are understood the question immediately after you read it, but let me explain for the weaker section of the students, those who do not understand immediately after reading. So here we have 2 spheres, one is uncharged, one is charged with 4 into 10 to the power of minus 8 coulomb. Okay, so it is placed in contact. Placed in contact means they are basically connected. Okay, they are connected. Both of them are conductors. So once you connect them, because they are identical, this is very important. If they are not identical, the solution of this question will be difficult and tricky. It is solvable, but it will be done in the next chapter. You need to know the concept of potential. But because they are identical means what? So if you have seen the cricket matches, what happens when some balls get deformed or slightly change the shape? They take an identical ball which is slightly better than the other one, but almost having the same thing as the original ball, right? So if you are following a cricket match, similarly here both of them are identical means they are exactly the same thing. So if you connect them, if you touch them, what happens is that the charge, this is the total charge, right? Now conservation of charge says that you cannot create or destroy the net charge. So this is the net charge. This amount of charge will remain same, but this sum of this charge will be transferred back to this object A, which was initially uncharged. Right now, how much charge will come to A? Because they are identical, okay, whatever initial charge was of the system, that charge will be divided into two halves. That charge will be divided into two halves. So basically 4 by 2. 4 by 2 means what? 2. So 2 into 10 to the power of minus 8 coulomb charge will be coming to sphere A, and 2 into 10 to the power of minus 8 charge will remain in QB. So basically identical means once they are connected, the charge will be distributed equally, okay, and the total charge will remain same. So what happened is that whatever object is charged, half of that charge will be transferred to the other uncharged object. Okay, in case it had some charge, say it had 1 coulomb, it had 3 coulomb. So in that case you have to add them and then divide by 2. Clear? So because it was 0, it was easier for us. So 0 and 4 means half of 0 plus 4 is 2. So 2 into 10 to the power of minus 8 will be transferred to A, and 2 into 10 to the power of minus 8 will remain in B. Okay, now they are, after that what happens is that now you have broken the connection and they are kept at certain distance. The distance is not given. Okay, so what we will assume that the distance is, say, x. Distance between them, say, x. Okay, that we have assumed. Right, now what? Charge and then remove to a distance such that the force of repulsion between them is 9 into 10 to the power of minus 3. So force of repulsion is given. So two charges, distance is unknown, force is known. You have to find what is the distance. This value is also given to you. So easy question. So F, what is the force? Force is given by K QA QB by x square. Okay, this force is given 9 into 10 to the power of 9. 9 into 10 to the power of minus 3. 9 into 10 to the power of minus 3 Newton. And that is equals to, K value is given over here, 9 into 10 to the power of 9. Anyway, we know that. So 9 into 10 to the power of 9. QA is 2 into 10 to the power of minus 8. QB has the same value, 2 into 10 to the power of minus 8. And the distance between them is unknown. So this will be x square. Okay, so this x we are trying to find. So x square will be equals to, now this calculation, slowly over time you will have an improvement. I am doing it slowly right now, but as we progress slowly, once your calculative abilities improve, we will be doing it faster. Okay, so here 2 into 2 is 4. Now let us check 10 to the power values. Minus 8 is minus 16 plus 9. So minus 16 plus 9 is 10 to the power of minus 7. Minus 16 plus 9, so it will be minus 7. And here we have, this will come down, cross multiplication, this is coming down, this is going up, right? So 9 into 10 to the power of minus 3. So 9 cancels and you get x square equals to 4 into 10 to the power of, this minus 3 will go up and become plus. So minus 7 plus 3, that is minus 4. Okay, so now this is x square. So you have to find x, not x square. So you have to take the square root of this. So taking square root, we can write 4 into 10 to the power of minus 2. Right? Square root of 4 is 2, square root of 10 to the power of anything is basically half, so 10 to the power of minus 2. Now this answer is in meters. So everything is in SI unit, so the answer is in meters. Now as I said, whenever you are converting from meter to centimeter or centimeter to meter, 10 to the power of minus 2 factor is there, so you can understand this is nothing but 2 centimeter. So correct answer is 2 centimeter, option D. Clear? Easy question. Now next, move on to the next question. Force between 2 point charges Q1 and Q2 placed in a vacuum at r centimeter apart is F. Okay, so again this question is related to force. So 2 point charges, here we have 2 point charges Q1. This question is basically a KCET level question, trust me. Q1 and Q2 placed in vacuum at r centimeter apart. So initially they are at a distance r centimeter. Centimeter, meter does not matter. Is F. So what is F? F is equals to K Q1 Q2 by r square. I am not converting centimeter into meter. That is just to distract you, so don't worry about it. So this is the force. Okay, force between them when placed in a medium having dielectric constant K at a distance r by 5 centimeter apart will be. So what will be the force in a dielectric medium? So if you remember our lecture, force in a dielectric medium is given by K Q1 Q2 root K into whatever the new distance whole square. This is the formula. You have to remember it. Okay, this is the equivalent distance. The derivation is there, derivation I have not done, so but you have to remember it. If it is not directly, entire thing is not in the dielectric medium, then there is a separate formula, slightly complicated, but I have not seen that question, so I am not doing that. Okay, so if you put the entire system in the dielectric medium, the equivalent distance becomes root K into R. Okay, root K, K is this, capital K, not the small k, this is small k. Coulomb constant is generally represented by small k, whereas dielectric constant is represented by capital K. So there is a small interesting fact about it. Now what is given here, K value is given 5 and R dash value is given R by 5. So you might think, okay sir, multiply 5 cancels, so we get same force. Actually not. So what do you have to do? You have to find root K R dash whole square. Let us do that separately. Okay, so if you do the square, you get K into R dash square. K value is 5. R dash is R by 5. So R by 5 whole square is R square by 25. So if you cancel, you get this as R square by 5. Okay, so put that value over here. So you get K Q1 Q2 R square by 5, right? So division of division, so this 5 will come up, right? And if you see that this entire thing is nothing but this force F, so 5F. So the new force will be 5F. Okay, 5 times the original force. Next question, 3 point charges Q minus 2Q and plus 2Q are placed on x-axis at a distance x equals to 0, x equals to 3 by 4r and x equals to r respectively from origin as shown. If Q is given by 2 into 10 to the power of minus 6 coulomb and R value is 2 centimeter, the magnitude of net force experienced by the charge minus 2Q. Okay, now this question is slightly longer in terms of calculations. Otherwise the concept is simple. So if the same question comes in KCET, instead of minus 2q, if they ask you to find the net force on plus 2q, which is much more easier to calculate, okay, because a lot of values will cancel. So you that will be a task, homework task for you to find the net force on 2q and mention the answer in the comment below. Okay, what will be the net force on this 2q? But let us understand this problem first. Okay, here we have to calculate the net force on minus 2q. So you have to understand what are all the forces acting on this minus 2q charge. There are two forces acting on this minus 2q charge. One force is because of this plus 2q charge, right? This is plus. So what is the symbol? Minus. This is plus. So minus and plus, what they will do? They will attract. So the first force is this one, say F2q. Okay, so I am saying this is 2q due to this charge, right? Now there is, in the distant apart, there is another charge, small q, sitting over here. So there will be a net force in this direction as well, and this is minus, this is plus. So again it is attractive, but it will be in this direction. So that force we are saying, say Fq. So as you can see, this charge is bigger and this charge is closer also. Bigger and closer means obviously this force will be bigger, this force will be smaller. So the net force is basically F2q minus Fq. Okay, so you have to find the net force. This is a numerical type question, so options are not given. So you have to solve it and put the answer in here. If this same question comes in KCET, they will give you the values as well. Okay. So first let us understand how to solve this question. So this total distance is r, this much distance is 3 by 4 r. So what will be this distance? So this distance will be 1 by 4 r, right? R minus 3 by 4, so this distance is 1 by 4 r. This is the only thing that we require. Now conceptually clear? So we have to calculate the individual forces, and for net force, bigger force minus smaller force, because they are acting on the same line. In case they are not acting on the same line, you have to do the vector addition, which will be a complicated problem. But this is a simpler problem. Only two forces you need to calculate. So let's calculate the first force, F2q. So K 2q into 2q divided by 1 by 4 r whole square. Now if you see that I am not using the negative sign of the minus 2q charge, because I have already said this force is attractive, so I have already find its direction. So while calculating force, if you find the direction clearly, no need to add the sign of the charge in the expression of force. Very, very important. Okay. So when you are finding the expression for force, in fact in case of fields also, if you are aware what is the direction, then you do not need to add the sign of the charge. If you are sure about the direction, that is the very, very important thing. Right? Now let's simplify it. 4k q square by 1 by 16 r square. Now if you see that I will not insert the values right now, I will insert the values after I simplify the entire equation. So it will be 4 into 16, that is 64. Okay. So this 1 by 16, 16 will go up. So it will be 4 into 16, that is 64 k q square by r square. Okay, so this is the F2q. Now what is the value of Fq? Value of Fq same. Only thing here, it will start from q. Q into 2q divided by 3 by 4 r whole square. Very, very important. Some students often forget to square the extra factor. They just add 3 by 4 r square, which is wrong. 3 by 4 whole square. Okay, so these are the common mistakes that student make. So 2k q square divided by 9 by 16 r square. So it will be, this 16 will go up, 32 by 9 kq square by r square. Okay, so this is the FQ force. So what is the net force? They asked you to find the net force. So net force will be F2q minus FQ. That will be equals to, now if you see that 32kq square by r square is common, right? This much is common. So 32, if you take 32 common, what is left here? You are left with 2. Okay, minus, because it is minus, because this force is smaller and in the opposite direction, so it will be minus. So 32 kq square by r square is taken common, so you are left with only 1 by 9. Okay, so now simplify 18 minus 1. Okay, 18 minus 1 by 9, that is 17 by 9. So this is very interesting. So I am just helping you how to do it. 1 by 9. So first 9 is the common LCM. So 9 to the 18 minus 1. So 17 by 9. Right. So you have to put that value over here and you will get into 17 by 9. Okay, now what you have to do, you have to put the values and then simplify it. Okay. So 32 into k value is 9 into 10 to the power of 9. Q value is 2 into 10 to the power of minus 6 whole square. Okay, divided by r value is 2 centimeter, that is 2 into 10 to the power of minus 2 whole square into 17 by 9. Okay, so 9 cancels, and whatever in fact the square will cancel. You will be left with 32 into 17 10 to the power of minus 12 plus 9 plus 4. Okay, this square also, this minus 2 will also become square and this will go up, so that will also become plus 4. So 4 plus 9 is 13 and minus 12, 13 minus 12 is 10 to the power 1, that is only 10. Now you have to check this out, the 10 to the power of calculations. You have to be smarter and faster while calculating the 10 to the power of values. Okay, so 32 into 17 is like 16 into 16 in plus another 16, that is 256. And it will be 272. So 32 into 17. So let me do a breakup for you here. So what I can do, 32 means 32 into 17, that is 16 into 17 into 2. So I have broken 32 into 2 parts, 16 into 2. Okay, so 16 into 17 is what? How to calculate 16 into 17? Okay, multiplied by 2 is easy. So 16 into 17 means both are very close to each other. So 16 square is easier to remember, that is 256. Okay, so 16 into 16 is 256. So 256, and what you have to do while calculating 16 into 17, 256 plus another 16, because that's why it is 17. Okay, so this is a trick. So it will be 272, right? So 272 into 2, so 272 into 2 is 544. Okay, so this is how you can calculate without using calculators. Now, as I said, stop using your calculators right now. You have to develop this skill of calculating without using calculators, and it does not come in one day, it comes over time. So you have to be prepared for that. So it will be 544 into 10, that is 5440. So correct answer here is 5440 Newton. Okay, now let's move on to the next question. As you can see, this is a long question. I will try to simplify it as much as possible. Answer itself is very long. Some symbol I think is distorted. Let's see. So two identical positive charges Q, capital Q, each are fixed at a distance of 2a apart, small 2a apart from each other. Another point charge Q naught with a mass small m placed at the midpoint between two fixed charges. Okay, for a small displacement along the line joining the fixed charges, the charge small q naught executes SHM, the time period of oscillation of the charge q naught. So this is a standard question. In JEE, this question, if you are preparing for KCET, this question will not come. But this question is very standard question in JEE because it used to be a part of derivation long back. Derivation is no longer there, but you might face question based on this. So this is actually a formula based question. Okay, even though the actual derivation is no longer part of your NCERT, so you can expect this question will not come in KCET exam. So let's see what is the question talks about. We have two charges, capital Q and capital Q, and at the center between them we have so this is the charges, and at the center we have another charge Q naught kept. Okay, the original distance between the charges is 2a, so that means we can say this distance is a, this distance is also a, like dipole, just like dipole. Okay, now it says that if you displace one of the charges in one of the this charge towards one of the charges, suppose you displace this charge by a small amount delta x, then this charge will start oscillating and you have to find the time period of that oscillation. Standard question. Those who have are preparing for JEE, they know this type of questions, right? Now how to do that? We will just basically be doing the derivation. So if you have remembered the formula and don't know how to derive it, that part we will be doing in our lecture today. Let me increase the size of the text so that you don't have any confusion. So this is delta x. Now what will happen if you displace it towards this charge? Towards this charge. So this charge, both of them are positive, so this charge will start repelling it more in this direction, okay, and this charge will repel it slightly less in this direction. When it was exactly at the center, the force of repulsion between these two charges were exactly equal and they are cancelling each other. But if you displace it slightly, the repulsion due to this charge will be more, repulsion due to this charge will reduce because the distance has increased. Now if you see that the displacement of the object in this direction, whereas force acting more on the other side, so displacement and force will be negatively related. First let us find the net force. So how to do that? It's like dipole treatment, so you are aware of it. So first we will say this was A and displacement is delta x. So what is the new distance now? So new distance will be A minus delta x. Okay, and this distance will be A plus delta x. So one is having A minus delta x, another one is having A plus delta x. So what is the force? Say F1, so this say A1, this say 2. So what is the force F1? Force F1 will be K Q naught by A minus delta x whole square, and F2 will be K Q naught A plus delta x whole square. Okay, this is the basic formula. Now as I said, force F1 is bigger, force F2 is smaller. Why? Because the charge is now closer to 1 than it is to 2. So what is the net force? So net force is basically F1 minus F2. And if you want to download the lecture PDF along with the solutions, what you have to do, you have to join our WhatsApp channel. The link of the WhatsApp channel is given in the description, so don't forget to join our WhatsApp channel if you have not yet joined, right? So let's start. F1 is given by, now you can see that K Q Q naught is basically getting common, so you can take that as common. K Q Q naught is common, and in bracket you get 1 by A minus delta x whole square minus 1 by A plus delta x whole square. Now if you are expert, you can do this directly. Okay, you can solve this directly and tell me the value. If you are not expert, you have to do the multiplication, then put it over here, then simplify and solve it. But if you have done the derivation in case of the dipole, then you are aware this can be simplified as 4a delta x divided by a square minus delta x square whole square, right? So this can be simplified like this. Now obviously this displacement delta x is very small, so delta x very small means delta x square will be much more smaller, so we can basically ignore this delta x square. Okay, this can be ignored. So once we ignore it, we get k q q naught. This delta x cannot be ignored. This is in the first of all, this is in the numerator and it has no addition or subtraction. If this was in addition or subtraction with something, then we might consider and ignore it. But here it was because it is subtraction, the a square value is much larger compared to delta x, so that's why we can ignore it. So sometimes students often face difficulty, so when to ignore something, when not to ignore something. That is also very important skill in physics. So if it is addition or subtraction, you can still ignore if it is a small quantity. If it is multiplication, you cannot ignore. Okay, because multiplying, even if it is smaller, say 0, then it will, entire term will be 0, so that's why you cannot ignore it. So 4a delta x divided by a square to the power square, that is a to the power of 4. So one of the a will be cancelled and you get a cube. So it will be 4 k q q naught by a cube delta x. So this is the force and this is delta x. Now as I said, because they are in the opposite direction, actually the net force and delta x, there will be a negative sign. I am not considering the negative sign for now, but anyway, what we know also that acceleration will be given by net force divided by the mass of this small q naught charge, right? So the what is the acceleration here? Acceleration, now you have to put the value of k also. So 4 into 1 by 4 pi epsilon naught q naught by a cube. So 4 cancels. Okay, so what is the acceleration? Acceleration is given by, there is a delta x also. Okay, so you get this as q naught by pi epsilon naught a cube m delta x. So you have divided by m, that's why this m is appearing over here. Now in SHM, if you remember, this equation can be compared. If it is executing SHM, then you can write this as omega square x. Here it is delta x. So acceleration is proportional to displacement, and as I said, because the direction is opposite, there will be a negative sign. For simplicity, I am not using that negative sign. So acceleration is proportional to displacement, but it is acting in the opposite direction. That's why this term can be called the omega square. So if you compare this term is nothing but omega square. Right, this value is nothing but omega square. So you have calculated the major part. So what is the value of omega? So omega is square root of this entire thing, q naught divided by pi epsilon naught a cube m. Pi epsilon naught a cube m. Now what is time period? Time period is 2 pi by omega, that is 2 pi. Now you have to take the inverse of it, right, because it is in division. So pi epsilon naught a cube m divided by q naught. Now if you see the options, 2 pi is not given in the common term. To 2 pi common is not given. Okay, so I think this is nothing but capital Q. Okay, this is capital Q. That's why it's coming like this. Okay, so basically this 2 pi you have to take it inside the square root, right? So if you take this 2 pi inside the square root, what will you have to do? You have to square this and then take it inside. So that will be 4 pi square. So 4 pi square will go inside the square root. So it will be 4 pi square. There is one more pi over here. So it will be 4 pi cube epsilon naught a cube m divided by q naught. Okay. So let's check the options. 4 pi cube epsilon naught m a cube by q naught. So correct answer is option A over here. Okay, solution is next page. Right? So if you are downloading it, you know where the solution is. Okay. Now next question. Two identical tennis balls, each having mass small m and charge small q, are suspended from a fixed point by threads of length small l. What is the equilibrium separation when each thread makes a small angle theta with the vertical? So everything is very, very important. We will come back to the expressions once we solve it. Let us understand the question. We have two identical balls of mass m and they have a charge small q. So mass m means what? mg is acting downwards. So we will draw the, basically what you have to do, you have to draw the free body diagram and the distance between them, say x. We are trying to find this equilibrium distance x. So once the system is in equilibrium, so basically two charges, same charge. So if you release them, what will happen? Each of them will repel each other, and because of the repulsion, they will settle at some distance. Okay, and if this angle with the vertical, suppose this is the angle with the vertical, if this angle is small, there will be some approximation we can do. If you have seen my bridge course, there I have explained what are the approximation for small angle. Okay, so those approximations we have to apply. What is given? This distance given is as L. Okay, and the mass is given as mg, and the charges are obviously given, so both of them are small q. Now let us understand what are all the forces acting on this system. That is a free body diagram. So free body diagram generally drawn after separating it, but I am drawing within this diagram only. I am not drawing for this charge, I am only drawing for this charge, right? So I am not separating it, but I am just drawing it in this diagram only, so that will save us some time. So this force is basically the tension force. Okay, now tension will have two components. One is in this direction. Okay, if this angle is theta, then this vertical angle will also be theta. This angle is also theta. So this component is t cos theta and this component is t sin theta. Right? And what else? Because of this charge, there will be a force of repulsion as well. So I am saying that force is Fq. If the system is in equilibrium, then we can say that all the individual component of forces are basically cancelling each other, right? So what's happening is that this vertical components of forces are cancelling each other. The horizontal components are also getting cancelled. right? So T is basically balancing the system. So what we can say? So we can say that T sine theta must be equals to FQ, right? So what is FQ over here? FQ is K Q into Q, that is Q square divided by the distance x square. Coulomb's law, simple Coulomb's law, two charges Q and Q are over here, Q, this is also Q. Okay, so K Q1 Q2 by R square, so K Q1 Q2 both are same, so Q square divided by x square. So this is the first part, T sine theta. Now as the angle is small, we can write this as T into theta. Theta is in radian. If theta is in radian, then sine theta for small theta, sine theta nearly equals to tan theta, nearly equals to theta. Okay, and cos theta nearly equals to 1. But provided theta is in radians, theta is in radians. So T theta is equals to K Q by x square. Keep it in mind. Keep it in mind. Now let us consider the horizontal balance. So what is the horizontal balance? Horizontal balance is T cos theta, sorry, vertical balance. Horizontal balance is this. So vertical balance T cos theta equals to mg. Now for small angle, what is cos theta? Cos theta is 1. So from here we can say T equals to mg. So what we will do, we'll put that value over here. So mg theta equals to kq by x square, or theta equals to kq by mg x square. Okay, so this is done. Next part is basically geometry. What geometry? So here is one charge, distance L, the total distance is x, so we are doing the half distance. A half distance, say, is x by 2, right? So half distance is x by 2. This angle is theta. Okay, so we have to find theta based on L and x by 2, then we have to substitute. That's it. So this is the geometry. So basically we have drawn this half triangle over here. Okay, so this half triangle we have drawn. Okay, so let us understand what is this. So this is theta, this is L, this is x by 2. Okay, and this angle is 90 degrees, right? So from here we can say that this is perpendicular, this is hypotenuse. So sine theta equals to x by 2 by L. Okay, x by 2 by L, or theta equals to x by 2 by L, or theta value you already know, it is k q by mg x square. Okay, so now let's simplify this. So we will get this as this x square will come to this side, so x cube by 2 equals to k q L by mg, right? Now these two will also come over here, so you have to take this two also over here. Now you have to put the value of k now. So 2 by 4 pi epsilon naught ql by mg. So they will cancel and we get this as ql divided by 2 pi epsilon naught mg. So x value will be this thing to the power 1/3, because here we had x cube. So now let's take the answer. Answer is given by q square L 2 pi epsilon naught mg to the power 1/3. So option B is correct in this case. So option B is correct, right? So be careful while answering such questions. Might be tricky, but if you follow the steps properly, you will get the answer. Also, I made a mistake over here. There was a square. Okay, I missed it. Okay, there was a square from this step, if you remember. That square got missed. Sorry for that. I know some of you will try to point me out in the comment below saying, sir, square is missing, square is missing. Yes, it is missing, is corrected. Okay. Also, be careful while calculating such questions. It might be tricky, it might be time taking, especially for JEE, but in JEE exam you get a little extra time, obviously, so that's why you can answer these questions without worrying too much about time. Okay, now let's see the question. This is also an interesting question. A metallic ring, here a metallic ring is shown. Okay, you can see this metallic ring is uniformly charged as shown in the figure. This question can come in KCET. Okay, as shown in the figure. AC and BD are two mutually perpendicular diameters. So diameter means completely. Electric field due to the arc AB to O. Electric field due to the arc AB, okay, to O is E. Okay, so electric field due to this arc is E at O. Okay, what would be the magnitude of electric field at O due to the arc ABC? So what will be the electric field due to this entire ABC arc? Okay, so that is the question. So how to solve it? So first we will, it is given that the electric field due to the arc AB is O, right? So what will be the direction? What could be the possible direction? Because it's a symmetric diagram, so the electric field will be exactly in this direction, making an angle 45 degree. Okay, this will be also 45 degrees because it is a symmetric diagram. This angle is 90 degrees, so that's why it is 45 degrees, and this will be the electric field E. Okay, now due to symmetry, each quarter, these are quarters, 4 parts, right? 1 quarter, 2nd quarter, 3rd quarter, 4th quarter. So each quarter will have exactly same electric field, but direction will be different. Okay, magnitude will be E due to the quarter BC. Electric field due to the quarter BC will have the same magnitude, and the direction again will be in this direction. This is also E. This angle is 45. This angle is also 45. Okay, so basically what is this? Two electric fields. What is the net electric field? Basically that's what we have to calculate. So what is the angle between these two electric fields? 45 plus 45. That means that angle is nothing but 90 degrees. So the angle between them is 90 degrees, and two vectors. So what is the resultant vector? The resultant vector or net electric field is given by square root of E square plus E square, right? Plus cos theta, cos 90 is 0. So that's why it is E square plus E square. Two perpendicular vector, always easy to find the net resultant, right? So those who have paid some attention in the vector chapter, they know that. Okay, so correct answer is E root 2 or 2 root 2 into E. Okay, so even though the answer is obvious, you have to check, and many students will answer 2E. I know, but answer is not 2E, it is root 2 into E. Now assertion and reason based questions. These questions are very popular nowadays. The outer body of an aircraft is made of metal which protects the person sitting inside from lightning strikes. The electric field inside the cavity enclosed by the conductor is 0. So obviously when you are traveling in an aircraft, okay, if there is a lightning strike on the aircraft, you are still safe inside. Okay, maybe aircraft actually usually go above the range of the lightning strikes, but when going up or during landing, okay, there may be cases where there is a possible chances that a lightning strikes the aircraft. Okay, in that case you are inside will be safe. Some mechanical problems might happen in the aircraft, but you will not get electrocuted. Why so? Because the aircraft is made from metal, okay, conductor. So because you are sitting inside that hollow conductor, you are basically shielded from outside electrical interferences, right? So that's why you will not get any electrocution inside. Okay, so both assertion and reason are correct, and reason is the correct explanation of assertion. So option A is correct in this case. Now these are the results from our Diksha campuses. Sorry for the picture, this is slightly off color. Anyway, so if you are someone who want to study from our Diksha campuses, you can check in the comment in the description section. There is a number given. You can call us and join our Diksha campus, in-house campus, where all the teachers teaching offline, and you can join there and you can improve your chances of securing a secure future for you or your brother or your relatives. Let's see. Next question. Consider a circular loop that is uniformly charged and has a radius a by 2. Find the position along the positive z-axis of the Cartesian coordinate system where the electric field is maximum if the ring was assumed to be placed in the xy plane at the origin. So it is placed in the xy plane, charged ring. Now this question, if I try to solve it in detail, it will be very long. Entire class will be over by that time. So basically it used to be a derivation. The derivation even though not there anymore, but the concept related questions time to time it comes in JEE. Okay, I have not seen in KCET, maybe NEET, but not for KCET. JEE obviously it might come. So you have a charged ring placed in the xy plane. So this plane is basically xy plane. Obviously it's a three-dimensional diagram. Okay, so these are all positive charge, and this is the z-axis. You have to find where the electric field gets maximum. So if you consider a charged ring, electric field basically varies like this. Okay, and there is a derivation for that. You can, first of all, you have to calculate the electric field due to this charged ring. Okay, KQX divided by x plus, so what was the formula? KQX divided by R plus X, sorry, R square plus X square to the power 3 by 2. This is the formula for electric field. And then you have to differentiate it, because it is along the z-axis. We can replace x by z. Okay, and then you have to find the condition for maximum, which you will learn in the application of derivative chapter. Okay, application of derivation chapter, AOD. There you will know that how to find maximum, how to find minimum, and then how to check whether it's a maximum or minimum. So those are complicated part, but what you have to remember is that in case of a charged ring, if the radius of the ring say given by r, then the maximum occurs at a distance of r by root 2. The maximum occurs at a distance of r by root 2. So the derivation part is there. Okay, so the where you will get this maximum? R by root 2. Now what is the radius given over here? The radius itself is given. So distance max, so z, where the electric field is max, is given by r by root 2. Now if you see, r is given as a root 2. So a root 2 by root 2, so root 2 cancels. So the distance will be a from the origin. The distance will be a from the origin. So correct answer is A. Next question. A point charge plus Q is placed at the origin. A second point charge plus 9Q is placed at D, 0, 0. In Cartesian coordinate system, the point in between them where the electric field vanishes is. Now this kind of questions can come in KCET as well. It's a null point related question. Now in this question, these two zeros does not matter. That means y and z coordinates are zeros, and as you see that all options also have these as zeros. Okay, so we will only consider that basically two charges, one is q, another one is 9q. So don't get confused, my 9 sometimes appear to be as q. So I have added this tail exclusively so that you can differentiate it. So this is 9. Okay, let me write it slightly different so that you can identify it. So 9q. So this 9 I try to write it like this. That's why it is slightly curved. So this is 9q, and you have to find the null point basically. So in this question I will do the mathematics. Later on in future classes I will teach you how to find it in a shortcut way. So don't try to remember all the shortcuts. Try to first understand the physics first. Then later on maybe shortcuts is important. Right? First let us understand that this charge is bigger, this charge is smaller. So, and both of them are same magnitude. So if both of them are positive, both of them are negative, then null point always occurs between the charges. Very, very important. Okay, so if both of them are positive, null point always occurs between the charges. So here, suppose, and it will be appearing closer to the smaller charge than to the bigger charge. Okay, and from this question, the distance between these two charges is basically small d. That is the basic meaning of it. If this is at 0, this is at d, that means the distance between them is d. Okay, this is how they are trying to trick you. Okay, if this question comes in KCET, they will directly tell you they are kept at a d distance apart or x distance apart. So that will be given to you, but because it's a JEE question, they try to trick you by giving you the coordinates, so you forget how to find the distance. So because one charge is at origin, another charge is d, 0, 0, that means the distance between them is d. Clear? If you have any doubt, don't forget to mention in the comment. So now say this distance is x. This distance is x. And this distance is d minus x. Obviously. Right? Now if this is origin, okay, plus q is placed at the origin. So coordinate for this point will be x, 0, 0. Right? This is 0, 0, 0. So basically what we have to do, we have to find the value of x. That is what we are trying to do. So what is the meaning of null point or electric field vanishes? Electric field vanishes means the electric field due to this charge at this point and electric field due to this charge at this point, they will be equal but in the opposite direction. So basically their resultant is 0. So what is the question? Question is calculate the electric field, compare them and find the value of x. So what is the electric field due to q? Electric field due to q is given by k q by x square. What is the electric field due to 9q? Electric field due to 9q is k 9q divided by d minus x whole square. Now if they vanish, if the net electric field is 0, that means EQ must be equals to E2Q. Okay, so just compare these two. So K small q divided by x square equals to K 9q divided by d minus x whole square. So as you can see, K cancels, Q cancels. Now square root both sides, you get 1 by x equals to 3 by d minus x. Okay, we have taken square root on both sides and we have ignored the negative sign. Obviously distance cannot be negative in this case. So d minus x equals to 3x. Right, d minus x equals to 3x. So from here we get d equals to 3 plus x, that is 4x, or x equals to d by 4. So the coordinate will be D by 4 0 0, that is option B. D by 4 0 0, this is the correct answer. Right? Not super difficult, only thing you have to calculate the electric fields and compare it. Another question, shown in the figure, a point charge capital Q is placed at the center of conducting spherical shell of inner radius small a and outer radius small b. The electric field due to the charge Q in three different regions 1, 2 and 3 is given by region 1 is this one where it is inside this shell. Okay, second region is this one when it is actually in the conducting area, and the third region is outside. Okay, now here you might think that it is basically kind of electrostatic shielding, but it is not electrostatic shielding. Electrostatic shielding is when the charge is outside, there will be no electric field coming inside, right? But in this case what happens is that electric field inside this shell, electric field inside, obviously it will not be zero. You can consider a Gaussian surface, and electric field will not be zero. But because it's a conducting sphere, electric field inside a conductor is zero, right? So electric field inside the conductor will be zero. So electric field in the region 2 will be zero. Again, when you go outside, electric field in the region 3 will not be zero. Because it's a not not conducting surface, so electric field in 1 and 3 are not zero. Electric field in region 2 is zero. So let's see the options. E1 is not zero, E3 is not zero, but E2 is zero. So correct answer is option B. Okay, this is the correct option. Next question. A thin infinite sheet of charge and an infinite line charge of respective charge densities plus sigma and plus lambda are placed parallel at 5 meter distance from each other. Points P and Q are at 3 by pi meter and 4 by pi meter perpendicular distance from the line charge towards the sheet of charge respectively. EP and EQ are the magnitudes of resultant electric field intensities at point P and Q. If EP by EQ is 4 by A for 2 sigma by lambda, then the value of A. So it is a typical JEE question. So what we have a charged sheet, we have a line charge, and we have 2 points, point P and point Q, towards the sheet of charge. Sheet of charge, let me redraw it little bit better. Infinite sheet, right? So it should be like this. Okay, this is also infinite line charge. The surface charge density is sigma here, the line charge density is lambda over here. Okay, so you have to find the electric field EP, EQ and EP. Okay, this distance, one of them P is 3 by pi and this is 4 by pi. Okay, so what is the electric field due to infinite sheet of charge? Electric field due to infinite sheet of charge at both points will be sigma by 2 epsilon naught. This is constant. Electric field due to a infinite sheet of charge is constant, which is given by sigma by 2 epsilon naught. Electric field due to the line charge will change for EP and EQ. So what is EP? Now let us understand the directions also. Okay, this is a positively charged, so electric field will be at P, it will be away. This is also positively charged, so electric field due to this will also be away. So there will be a subtraction. Now let's see which one is positive, which one is negative. I am assuming because the distances are given from the line charge, I am assuming this distance is positive. In case it is not, we will keep the same nomenclature for both the distances, and we will try to, if these both are negative, they will cancel anyway. Okay, so EP is, first we are doing the line charge minus the surface. Surface is constant, that's why I am not adding any point. So what is the line charge? Electric field due to a line charge. That is given by 1 by 4 pi epsilon naught 2 lambda by r. If you remember, that was the formula I taught you. I told you that that might come handy. In this case, it is not. You can simply cancel it. So it will be 2 pi epsilon naught by into lambda by r. Now what is r over here? R is given by 3 by pi. Okay, so in this case 3 by pi. Sorry, 3 by pi, and this is given by sigma by 2 epsilon naught. Okay, and from here we can write, obviously this pi cancels, we get this as 3 to the 6 epsilon naught, so lambda by 6 epsilon naught minus sigma by 2 epsilon naught. Now it is given that 2 sigma equals to lambda, so we have to put that value of lambda over here, so we get this as 2 sigma by 6 epsilon naught, minus sigma by 2 epsilon naught. So as you can see, the value is coming negative, but don't worry too much. Sigma by epsilon naught is common. We can write 1/3 minus half, so it will be 2 minus 3, that is minus 1 by 6. So as I said, we should not worry too much about negative or positive, so you get this as minus 1 by 6 sigma by epsilon naught. Okay, now we have to calculate the same thing for EQ as well. Okay, sigma by epsilon naught will obviously be common, and we just need to write this step. Okay, so here it will be sigma by 2 cancel, sigma by 4, so it will be 1 by 4 minus half. Okay, because how can I say that? Because it was 3 pi, so here we got 3 by pi, so here we got 3. So here it is 4 by pi, so we will get 4 over here. So it will be minus sigma by 2 epsilon naught. Okay, so sigma by 2 epsilon naught is EQ, and EP by EQ value is given over here. Okay, EP by EQ value is given over here. Let me erase this. So now let's divide it. So what do we get? EP by EQ equals to 1 by 6 divided by 1 by 2. Minus minus cancels. So you get this as, this will go up 1 by 3. 1 by 3. Now it is given that 4 by A. Okay, so it is given as 4 by A. So you have to write it as 4 by 12. Right? So 4 by 12. So the value of A is basically this. So value of A is 12. Okay, clear? In case I made any calculation error, please do mention that in the comment below what calculation error I have made. I will acknowledge that, but I don't think I have made any calculation error. Right? Next question. Charges Q1 and Q2 are at points A and B of a right angle triangle OAB. So OAB is the right angle triangle, and charges Q1 and Q2, let me bold it so that you can see this is Q1 and this is Q2. Okay, image quality is slightly bad. So this is X1, this is X2. Okay, charges Q1 and Q2 are points A and B of the triangle OAB. The resultant electric field at point O is perpendicular to the hypotenuse. Then Q1 by Q2 is. So the resultant electric field is perpendicular to hypotenuse. That means this angle is 90 degrees. Okay, if say how to find the resultant, we will come to that. But first let us do some geometry. If this angle say theta 1, then this angle will also be theta 1. If this angle is say theta 2, this angle will also be theta 2, right? These are the basic geometry for right angle triangle, right? These two angles should always be 90 degrees. So theta 1 plus theta 2 will be 90 degrees, right? And this angle is 90 degrees. That means if this is theta 2, this will be theta 1. If this is theta 1, this will be theta 2, right? Now let's draw the diagram once more. I have to draw the diagram. Okay, so this is a triangle. So electric field due to Q1, this distance is x1, so electric field will be in this direction, right? Say this electric field is E1. This is Q2, this distance is x2. This tag does not matter right now. Okay, so this will be in this direction, say E2. Okay, and this is along this direction, perpendicular direction, and we have identified that this angle is, if this angle is theta 1, then this angle will also be theta 1, and if this angle is theta 1, so this and this are basically alternate angle. So this will also be theta 1, not alternate, sorry, opposite angle, right? Opposite angle. These two angles are opposite, so I can say this angle will be theta 1. Thus only we need to apply the basic principle of vector addition angles. Okay, the resultant angle. So this resultant angle theta 1 is known. The resultant angle theta 1 is known. So tan theta 1 is basically E1 sine of the angle. Sine of the angle means this angle, okay, that is 90 degree, sine 90 degree. By geometry they are E1 and E2 are perpendicular, right? So sine 90 degree divided by E2 plus E1 cos 90 degree. Now cos 90 is 0, so you get this as E1 by E2. Okay, so tan theta 1 basically E1 by E2. And what is tan theta 1? Now we have to come back to this triangle, right? What is this tan theta 1? So this is theta 1, this is base, and this is perpendicular. Some people have curly brown hair turned permanently back. So tan theta 1 is perpendicular by base. Here perpendicular is x2 and base is x1, so x2 by x1 is the tan theta 1. So let's put that value here, x2 by x1. Okay, now what is E1? E1 is k q1 by x1 square, right? And E2 is k q2 by x2 square. So we have to put that value over here, and what we will get? We will get x2 square by q1 x2 square by x1 square q2. Okay, we are trying to find x1 by x2, right? x1 by x2. So x1 by x2 q1 by q2. q1 by q2 is x2 into x1 square by x1 into x2 square, that is x1 by x2. Okay, so it will be x1 by x2. This is the correct answer. Little tricky but solvable. Next question. Consider a sphere of radius capital R which carries a uniform charge density rho. If a sphere of radius r by 2 is curved out of it as shown in the ratio capital EA by EB of the magnitude of electric field EA and EB respectively at point A and B due to the remaining portion is. So this is a very standard problem. Here we have a uniform sphere. It is not a ring, it is a sphere. Okay, and you have curved out a portion from this. Okay, so you have cut this portion from the sphere. And what is the ratio of electric field at this point and this point? Very, very interesting question. Okay, so how to find that, how to do that? To solve this question, what we have to do, we have to know few things. As I told you, I have not derived this during my lecture, but the formula you have to remember that electric field due to an uniformly charged sphere. Here the sphere is not conducting obviously, and it is uniformly charged means there are charges placed inside the sphere as well. If it is a conducting sphere, it would have been easy. If it is not conducting, then you have to use this formula. What is this formula? It is the charge density divided by 3 epsilon naught into small r. When we are going to use this formula is for all points inside the sphere. All points inside the sphere, this formula we are going to use up to the surface. Up to the surface. For surface, obviously for surface, the formula becomes E equals to sigma by 3 epsilon naught capital R. Okay, and any points outside the surface, the formula is slightly tricky. Outside, the formula becomes E equals to rho by 3 epsilon naught is common. It will be R cube divided by R square. Here R is greater than capital R. Here R is less than equal to capital R. Okay, so up to R this formula is valid. Okay, for surface obviously this small r becomes capital R, so that's why this is the on the surface, and for any points outside the sphere this is the formula. Okay, so this in terms of surface charge density, and this formula you have to remember if you are doing JEE. Okay, for JEE students these formulas are very, very important. For KCET students it is optional, you don't need to learn it. You can skip that, you can use the formulas that you have studied in my lecture. Now so now that is these formulas are applicable when the sphere is complete, full, right? But here in this question the sphere is not complete. Why? Because we have cut a specific portion out from this full sphere, right? So that's why this question becomes slightly tricky, but this kind of questions are common in JEE. So what we will do, we will first we will consider that the entire sphere is this portion of the sphere is basically can be considered to be a uniformly charged sphere with a surface charge density minus rho. Very, very important. The surface charge density of this sphere can be considered as minus rho, and then we can apply our formulas that we know, right? And we have to apply the superposition principle as well. So basically what we are doing what we are doing here, we are basically converting this sphere into one complete sphere of surface charge density rho, and one sphere which is cut out from it as minus rho. Okay, so this is the sum of these two spheres. This sphere can be considered to be sum of these two spheres. So if you take this sphere and put it over here, then plus rho minus rho gives you 0 over here, right? So that's why we can consider this sphere having hollow portion can be considered into two spheres, one having full completely filled sphere of charge density rho, and one completely charged sphere of charge density minus rho. Okay, clear? If you have doubt, you have to watch it once more so that your doubt is cleared, right? So this is a very common type of questions, and when finding the electric field at any point, when we are finding the electric field at any point, you have to consider the electric field due to this portion and electric field due to this portion as well. Okay, now for electric field at point A, electric field at point A is easy. Electric field at point A is easy. Why easy? Because for this point is basically lying on the surface of this hollow sphere of surface charge density minus rho, and because there is no influence of this charge by Gauss law, if you draw the Gaussian surface, okay, this outside sphere has no influence, no charge from this outside sphere is getting covered inside it. So electric field at point A can be written using the formula for electric field on the surface of the sphere, that is EA can be written as rho by 3 epsilon naught into r by 2. Okay, here radius is given by r by 2, so that's why this is the formula for electric field on the point A. Now when you are trying to find electric field at point B, then the things is slightly complicated. Okay, so how to do that? Electric field at B can be written by the electric field due to the complete sphere, this bigger complete sphere, which we already know, and one more thing, there will be a negative sign over here because this charge is negatively charged, so that's why there is a negative sign. Anyway, don't worry, negative sign will cancel. So electric field due to the bigger sphere, what is the electric field due to the bigger sphere? Rho by 3 epsilon naught. Rho by 3 epsilon naught. And if you want to download the lecture notes, don't forget to join our WhatsApp community. The link for that is given in the description. Please don't forget to join it. Right, so rho by 3 epsilon naught times r. This is the electric field due to the bigger sphere. Now we have to find the electric field due to the smaller sphere. So electric field due to the smaller sphere, let me write the electric field due to the smaller sphere first. Okay, let me ignore this negative sign. Let me keep it positive only. Okay, we will consider only magnitude because magnitudes are important, so magnitudes we are calculating. So electric field due to the bigger sphere first, rho by 3 epsilon naught r. Now we have to find the electric field due to this smaller sphere again at this point. So now this smaller sphere, that's why this is negatively charged, that's why there is a negative sign over here, and we will consider rho positive. So what is the electric field due to this sphere at this distance? Okay, so now this point lies outside this sphere. This point lies outside this sphere, so we will be using the formula rho by 3 epsilon naught, okay, r cube, that is here r by 2 whole cube divided by the distance. So what is the distance over here? The distance is r by 2 plus r, that is the distance in this case is 3r by 2. Clear? This is center between distance from the center, right? So this distance is 3r by 2, right? So it will be 3r by 2 whole square, right? R cube by small r square. So r cube is r by 2 over here and small r is 3r by 2 square. So you might get confused, so you have to be very cautious, and why you are applying that you have to understand. Why you are applying this formula, that you have to be very conscious about. What is the radius over here, what is the distance over here, these things you have to be clear in your mind, right? Minus, so r cube by 8 into 4 by 9 r square, right? This one 4 by 9 r square. So r square and r cube, only one r is left, and here we have 1 and here we have 2. So what we got? We got rho by 3 epsilon naught r, also r is common, so let me take r common. So we get here 1 minus 1 by 2 into 9, that is 18. So here we get rho r by 3 epsilon naught 17 by 18, right? 1 minus 1 by 18, that will be 17 by 18. So this is the EB. Now what we have to do, we have to find the ratio of EA and EB, right? That is our target. So EA by EB, obviously you can see that rho by 3 epsilon naught r will cancel. Okay, so what will be in the top? In the top will be half. This half, r is cancelled, so only half is left, and in the denominator we have 17 by 18, right? So it will be half into 18 by 17, or it will be 9 by 17. Okay, so it will be 9 by 17. Now if you see the options, none of the options are 9 by 17. So is it a bonus question? No. You have to check the options in case there are some calculations are still possible or not. Okay, so for example, 18 by 34, if you cancel this, it will be 9 by 17. You can cancel, you might try to cancel this as well, this as well, this as well, but none of them will give you this 9 by 17. So correct answer in this case is option A. So this is also a style of giving you a questions where the option is not direct. You may need to multiply it with something to get the correct answer. Now next question, two small spherical balls of mass 10 grams each with charges minus 2 microcoulomb and 2 microcoulomb are attached to two ends of a very light rigid rod of length 20 centimeter. The arrangement is now placed near a infinite non-conducting charge sheet with uniform charge density of 100 microcoulomb per meter square, such that length of the rod makes an angle 30 degrees with the electric field generated by the charge sheet. Net torque acting on the rod. So this question is basically a dipole question, but they have not said this is a dipole. They said this is a dipole like this way. Okay, so there is a way of saying that this is my nose, no, this is my nose. So they have did that in this question. So we have a charged sheet, okay, infinitely long charge sheet like this, and we have a dipole at some distance, and this dipole makes an angle 30 degree with the electric field. So this is the electric field direction, this is the dipole direction. So So this is 30 degrees. And you have to find the net torque acting on it. So what is the formula for net torque? Formula for net torque is PE sin theta. So what is the formula for P? P is dipole moment, which is charge into distance, right? And what is the electric field due to a infinite sheet of charge? It is sigma by 2 epsilon naught, and sin theta obviously in this case sin 30. So we will put these values one by one and we will try to simplify it. So charge is 2 microcoulomb. 2 micro means 2 into 10 to the power of minus 6. Distance between them is 20 centimeter. So 20 into 10 to the power of minus 2. Right, now why they have not mentioned it as a dipole? Because the distance is slightly bigger. 20 centimeter is not small distance, so that's why by definition you cannot call it as a dipole, but by formula you can still apply the dipole torque acting on a dipole formula. Okay, that is the beauty. Now the charge density is 100 microcoulomb. So 100 micro, again micro means 10 to the power of minus 6. Okay, and 2 epsilon naught. Epsilon naught is given 8.85 into 10 to the power of minus 12. So as you can see, the value is not super good. If they had given a value which they can cancel this, the answer result would have been slightly better, right? Anyway, sin 30 is half. Now you have to put the values and calculate it, right? Now if you see that 10 to the power of minus 6, 10 to the power of minus 6 will cancel with 10 to the power of minus 12. Right, so they are in the top, so they will cancel with the whatever is in the bottom. These two will cancel with these two, right? And 10 to the power of minus 2 will cancel with 100. 10 to the power of minus 2 means 1 by 100, so that will cancel with 100. So what we have, so the torque acting on this is 20 by 8.85, which is almost 9. So 20 divided by 9, which will be 2 9s are 18, so it will be somewhere close to 2. This value will be somewhere close to 2. If you approximate this 8.85 to be 10, the next integer number, right? So that is also a technique. Whenever we are having difficulty to understand what will be the value 8.85, if you approximate this value to be as 10, then 20 by 10 is 2. Now we will see what are all the options which have this 2. Right, so as you can see, this has only one value which has a 2 value, so this is the correct answer without any doubt. And as we have we are saying this is 8.85, so the value, final value will be more than 2, so this value is more than 2.24. okay. Now next question, another assertion and reason based question. A net dipole moment of a polar linear isotropic dielectric substance is not zero even in the absence of an external electric field. Now here this dipole topic we will study again in detail in our next chapter, but as we know that molecular dipole moment is not zero. Molecules, individual molecules still have dipole moment if it is a polar molecule. Okay, the molecular dipole moment is not zero. Molecules still may possess dipole moment, and in case of non-polar it is zero in case of absence of electric field. But the net dipole moment means what? So there is a dipole like this is not zero, but net dipole moment means if you consider a complete substance, here we have say one more dipole like this, plus minus, and here we have one more dipole like this, minus plus. So they are randomly oriented. They are so randomly oriented that the net dipole moment of the dielectric medium or the polar medium is not zero. Is equals to 0. So the net dipole moment is 0 no matter polar or non-polar, okay, in absence of electric field. Okay, because they are randomly arranged, and any addition of random numbers, when it are plus and minus both are involved, the addition of random numbers will be 0. Okay, this is a mathematical identity. I am not going to do that. In absence of an external electric field, the different permanent dipoles of a polar dielectric substance are oriented in the random direction. So this is correct. This statement is correct, and if it was given it was 0, then this would have been the correct explanation, right? If this was given that net dipole moment of a polar linear isotropic dielectric substance is 0, then this is the cause, this is the effect, this is the cause, this is the effect, this is the reason, this is the statement, right? But because there is a not, that means assertion is not correct, but reason is correct. So A is not correct, but R is correct. So option D is correct answer for this question. Clear? Assertion and reason questions always read twice before answering. A dipole with two electric charges of 2 microcoulomb magnitude each. So one dipole only, one has 2 microcoulomb, another one will have a minus 2 microcoulomb with separation distance 0.5 micrometer. Now because now distance is smaller, they are directly saying this is a dipole. Okay, is placed between the plates of a capacitor such that its axis is parallel to the electric field established between the plates when the potential difference of 5 volt is applied. The separation between the plates is 0.5 millimeter. If the dipole is rotated by 30 degrees from its axis, it tends to realign with the direction due to a torque. The value of the torque is, so again torque value is PE sin theta. Now in this case, P, so we know the formula. P is what? Q into distance. Now in case of, this is the distance of the dipole, so let me write it like this, Q into L. Let me write it like this. So this is the dipole moment. Now electric field inside the plates of a parallel plate capacitor, that we will discuss in our next chapter, but because this is directly related to torque and it is considered to be a question from this chapter, I am discussing this question. Some of you have gone through that chapter already in your colleges or in your whatever you are teaching, whatever you are studying apart from our channel. Maybe you have know that. If you don't know, the electric field due to a in between the plates of a capacitor, so this is the capacitor. Okay, if the distance between the plates is D, if the potential difference between the plates is V, then the electric field in the region inside is given by V by D. Okay, so this is the formula for electric field inside the plates of a parallel plate capacitor. Okay, we will discuss that in detail in our next chapter lectures. Okay, so sin theta. Now all the values are given, so we just need to put the values and calculate it. Okay, so this is V. Everything is given. See, 2 microcoulomb, that means 2 into 10 to the power of minus 6. Distance is given 0.5 micrometer. 0.5 micrometer means 10 to the power of minus 6. Again, voltage is given as 5 volt and distance is given as 5 millimeter. So 5 millimeter means 5 into 10 to the power of 5 or 0.5 millimeter. 0.5 millimeter means what? 1 millimeter means 10 to the power of minus 3. So 0.5 millimeter means 5 into 10 to the power of minus 4. Okay. So 0.5 millimeter means 5 into 10 to the power of minus 4. Right. So let us cancel this 5 and 5. 2 into 0.5 is 1. So what we got? 1 torque, and also we have one more thing. We have sine theta, sine 30. Sine 30 means sine theta is half. Okay, so that is also there. So 5, these two cancels. So what we have? We have 0.5 into 10 to the power of minus 12, minus 6, minus 12 plus 4. This is in division, plus 4, so it will be 10 to the power of minus 8. Okay, 0.5 into 10 to the power of minus 8, or it will be 5 into 10 to the power of minus 9 SI unit, Newton meter. Okay, or nano Newton meter. Okay, some cases you might find that it is given in nano Newton meter. So be careful and choose the options correctly. So it will be 5 into 10 to the power of minus 9. So this kind of questions are very common in JEE, and you might see some of such questions in your KCET exam as well. This is very simple, easy formula. Only thing you have to calculate each and every term and then put that in the equation. Next question, an electric dipole of mass m, charge q and length L is placed in an uniform electric field E equals to E naught I cap. When the dipole is rotated slightly from its equilibrium position and released, the time period of its oscillations will be. So here we have a dipole. Okay, and it is displaced slightly, so say a small angle theta. Once it would displace it, what will act on it? There will be a torque act on it. Okay, what is the torque? Torque is given by PE sin theta. Now for small value theta, when the displacement is small, okay, so basically what is that? There is an electric field. Initially electric field and dipole moment are aligned, but if you displace it by small amount, what will happen? It will start oscillating. Okay, so that oscillation, time period of that oscillation you want to calculate, and this is only valid when the displacement is small. So for small displacement, this can be we can write this as PE theta. Okay, and from the rotational geometry, we can say that tau is nothing but I omega equals to PE theta. So basically we will calculate I omega from this, I alpha, I alpha. Alpha is angular acceleration. Okay, same as linear motion. In linear motion, force was given by ma, father equals to ma. In this case, tau equals to I alpha. Okay, so they are aliens. That's why it is tau equals to I alpha. Right? Same thing. So in case of linear motion, we calculate acceleration and we compare it with omega square x. In case of rotational motion, we calculate alpha and we say that alpha equals to omega square theta. Same way we calculate omega. Okay, so first we have to calculate I. How to calculate I? So here we have 2 point masses. Obviously they are not linked, so they are dipoles. So if you consider this is mass m, this is mass m, and obviously the axis of the dipole is this. So what is the distance from this? If total distance say 2a, then this distance is a, this distance is a. So what is the dipole, what is the angular momentum or moment of inertia from this point? The moment of inertia of this mass is half mr square. So moment of inertia of the point mass is not half mr square, it is only mr square. So that is in this case m a square, right? So this is m a square, and because this is m a square, this is also another mass, this will also be m a square. So total moment of inertia is m a square plus m a square. So that is 2m a square. That is the moment of inertia. So let's put these values over here. 2m a square alpha equals to p is what? P is q into 2a. Q into 2a, because remember here we have assumed the distance to be 2a, that's why I am using 2a in the formula. That's it, that is the reason. So q into 2a, and electric field is given E naught and theta. Okay, so from here we can calculate alpha. Alpha equals to q into 2a E naught divided by 2m a square theta. So 2 cancels, one of the a will remain in the denominator, so you get this as q E naught by m a theta. Now here if you see that in the question the length is given as L, so from there we can say A is basically L by 2. So that substitute you have to do it over here only. So alpha equals to 2q E naught by ml theta. Okay, so this value is nothing but omega square. So what we can say is that omega square is basically this value, and time period is 2 pi by omega. Time period is 2 pi by omega, so that is 2 pi square root of inverse of this. So ml first divided by 2q E naught. Okay, so it is ml by 2q E naught. So correct answer option C. Okay, clear? Why 2 comes over here? Because we have to substitute A with L by 2. So L by 2 means that division 2 will go up, right? It will come up, right? This 2 will come up, that's why 2 is coming over in the denominator. Be careful with these values. Students sometimes get confused, and even though they know the process, they do not able to answer the questions. Now next question, determine the electric dipole moment of the system of 3 charges placed on the vertices of the equilateral triangle as shown in the figure. So here you have to find the net electric dipole moment of this system. So first let us understand how to do that. So if you check the diagram first, here we have plus q, here we have minus 2q, here we have plus 2q. So net charge of the system is 0. It is very, very important to check if the net charge of the system is 0 or not. If the net charge is 0, then only you can find the dipole moment of the system, right? So what we will be doing, we will divide this minus 2q charge into 2 parts. How to do that? Let's see. So we will consider 2 charges, minus q and minus q. We can do that, right? We have divided this 2 minus 2q charge into 2 minus q charges. So this is a dipole. I think I have solved one similar question in my lecture. So this is a dipole, this is another dipole. Okay, and we will find the dipole moment of individual dipoles. Now what is the direction of dipole moment? Direction of dipole moment is from negative to positive. So this is one, this is another. Now if you see that both of them have equal amount of charge, right? Minus q plus q, minus q plus q. So the charge is same and the distance is also same. So what we can say is that the magnitude of the dipole moment will also be same. Why so? Same charge, same distance. Q into L is same. Right? Now what we have to do? We have to find the resultant. How to do that? To find the resultant, if you see that this is a equilateral triangle, L, L, L. Right? So it will be basically in this direction. You can divide any of these two into two components, one along this, another along this. Similarly, this also in this direction and in this direction. So the resultant in dipole moment, these two will cancel each other. So resultant dipole will be in this direction. Now you can apply the vector addition law. This angle is 30. This angle is 60. Or you can apply what should I say? You can apply the component factor as well. But I am not using the component factor here. I am using the resultant of two vectors, which will be, I think, might be slightly easier for you. Minus Q. So this is the resultant dipole moment. Now resultant dipole moment, you can see the direction is along the negative of y-axis. So definitely it is minus j cap. So you can even guess the answer without even solving it. Okay, the dipole moment is along the negative y-axis. So obviously the correct answer is option D. Okay, minus j. So only one minus j is over here. So this is the correct answer. Okay, if you want to do the calculations, that also is possible. How to do that? The net dipole moment is basically square root of p square plus p square plus 2 into p into cos 60. Okay, the formula for resultant of two vectors. Okay, here the angle between them is 60 degree. Why? All the angles are 60, equilateral triangle. So it will be p square, p square, p square. So there are 3 p squares, p square, p square, p squares. Okay, so it will come out of the square root and it will become p square root of 1 plus 2 into cos 60 is half. So another one. So it will be root 3 into p. So root 3 into p is what? P is q into charge L. So root 3 ql, and because it is along the negative y-axis, so the direction y is net electric field, net dipole moment is minus root 3 p j. Okay, why minus? Because it is along the negative y-axis. This is positive y-axis, this is negative y-axis. Very, very careful. Okay, so this is negative y-axis, this is positive y-axis. Okay, so don't fall for the trap and answer anything randomly. Okay, this will be minus root 3 qlj. Why minus? Negative y-axis, j represents y-axis. That's why this is the answer. Now next question, a particle of charge minus q and mass m moves in a circle of radius r around an infinitely long line of charge of linear density plus lambda. Okay, then period will be given as. So what is the question? A particle of minus q and mass m moves in a circle of radius r. So here we have a infinitely long line charge. Okay, line charge density is given by plus lambda. Here we have a circle on which a negative charge is rotating. A negative charge is rotating in this circular path. Okay, and they asked you to find the time period. Now this question is partly related to moving charges and magnetism, but you can solve it from the concept of this chapter as well. The line charge is passed through the center, not like this. So the line charge is passed through the center. So you can consider it like this. and the circle is like this. The three-dimensional picture. So either I have to draw using dot or cross. So I am not using dot or cross. I am just using a slightly configured figure so that you can understand it. Now the electron which is orbiting over here, or the negative charge which is orbiting over here, okay, why it will orbit? First of all, why this negative charge will orbit in this case? Because it will experience something which is called centripetal force. Okay, so whenever something is rotating, it requires to have a centripetal force, and some external thing has to provide that centripetal force. Mostly it is a forces are distance, which is for example electromagnetic force or gravitational force. They generally tend to provide the required centripetal force. So in this case, what is the electric field over here? Say E. Then what is the centripetal force required? Centripetal force required is Q into E. So you have to find the electric field. So radius of the loop is given by small r. So the distance from the infinite wire is also smaller. So what is the electric field at a distance? It is, if you are following my class today, you know that electric field due to a infinitely long wire is 1 by 2 pi epsilon naught lambda by distance. So in my lecture I used 2 lambda by 4 pi epsilon naught r, but in this case it is not required. In this case it is required, sorry. In this case it is required because because the Coulomb constant is given as K, right? Coulomb constant means 1 by 4 pi epsilon naught. So electric field is given by 1 by 4 pi epsilon naught 2 lambda by r, right? That was the formula. Now what is this 1 by 4 pi epsilon naught? This is Coulomb constant, right? So instead of writing this, what we will do, we will write this as 2k lambda by r. Now understand why I have written it like this, why these two comes. Many students get confused with these two, and that's why I always ask students to remember it in the standard form, so that in case some there is only 2 cancellation, you can do that anytime. But if you don't remember it, you will basically forget and your answer will be wrong. So electric field into charge, that is 2k lambda by r. This is the centripetal force. Now there is one more formula given for centripetal force, which is m omega square r. This is another formula for centripetal force. So from this we will calculate omega and hence the time period. Okay, so omega square is given by 2k q lambda by m r square, m r square. Okay, so omega is basically square root of 2k q lambda by m r square. Now what is the time period? Time period is 2 pi by omega, that is 2 pi into square root of m r square divided by 2k q lambda. Okay, so it will be 2 pi. Now if you take this r square out of the square root, if you take this r square out of the square root, you will get this as 2 pi r, right? So 2 pi r square root of m by 2k q lambda. So correct answer option B. Okay, not difficult but tricky. Yes, obviously tricky. An electron is moving under the influence of electric field of an uniformly charged infinite plane sheet S having surface charge density plus sigma. the electron is at t equals to 0, is at a distance 1 meter from S and has a speed of 1 meter per second. The maximum value of sigma if the electron strikes S at t equals to 1 second is alpha into m e naught by E c by m square. The value of alpha is another problem based question. So let us understand the question. Here we have a infinitely charged sheet, and an electron is moving of mass m and charge E. Okay, it is moving towards the sheet with a velocity of 1 meter per second, and the distance is 1 meter, and this is at t equals to 0. At t equals to 1, the electron hits the surface. Then what is the value of alpha? Okay, the maximum value of sigma is given by this. So this is the value of sigma. So sigma is given as alpha m epsilon naught by E. Basically this is the meaning of that. Maximum value of sigma is given so and so. What is the meaning of that? Sigma is equals to this, and then you have to find this alpha. That's it. So how to do that? First you have to find what is happening over here. So the thing that is happening over here is that this electron was moving towards the plate. It is also experiencing a force. Okay, what is that force? The force here is given by Q into E. What is the electric field? Electric field is given by Q is charge of the electron, and the electric field is given by sigma by 2 epsilon naught. This is the force. If this is the force, what is the acceleration? Acceleration is father by mother. Okay, so it will be E sigma by 2m epsilon naught. Okay, this is the value of acceleration. Now what? Now we have to apply the formula for displacement. S equals to ut plus half at square. Okay, so this is the formula that you have to apply, but here be careful what is the direction of acceleration. Now whenever we are using this equation, you have to be careful and identify the directions and signs properly. That is very, very important. One more thing I would like to do, I like to substitute the value of sigma from this in this, and we will see what is the actual value. Half E by m epsilon naught into alpha m epsilon naught by E. So E cancels, m epsilon naught cancels. So you get E A equals to alpha by 2. Okay, so this is the value of acceleration that we have calculated. Now remember that in this case the electron is moving in this direction. The force acting on this electron, also electron is basically negative charge. So negative charge means force will be opposite to that of the electric field. This is a positively charged plate, so electric field will be in the outward direction, electric field, right? So negatively charged particle moves in the opposite direction, right? So velocity is in this direction, acceleration is also in this direction, but the displacement you are measuring from the plate. The displacement is negative. The displacement S in this case is negative. Very, very important part over here. The main question, main problem that arises, because if you apply the displacement to be positive, you will get the value of alpha to be 0, which is not correct. Okay, displacement here will be negative because everything is in this direction. Displacement is in the opposite direction. So minus 1 equals to u is 1, time is given 1 second, plus half a is alpha by 2, right? A is alpha by 2 times t square means 1 square, so which is basically 1. Anyway, it is my duty to write it. So 1 square. So now you get minus 1 equals to 1 plus half. One small correction over here, the displacement will not be negative, but only thing that can be negative over here is the speed. Now this question as it is itself is incomplete. Okay, the direction of the speed has to be mentioned, which direction it is moving. If it is moving in the direction of sheet itself, if the electron is moving in the direction of sheet itself, then it will anyway reach to the sheet in 1 second, and in that case the value of alpha will be 0. But if the particle is moving in the opposite direction, and because of the electric field it gets attracted towards the it is moving in this direction, okay. Now it is not mentioned which direction it is moving, under the influence of the electric field, that's what it is mentioned. Towards, away from, that information is missing. So if this question comes as it is an incomplete question and you will be given a bonus mark. Okay, but because we are slightly smarter and we realize that if it is moving in the direction of sheet, it would have anyway reached to the sheet in 1 second. So in that case, what we can say that the electron was moving away from the sheet, and because of the electric field it gets attracted towards the sheet, and that's how it is hitting the sheet, right? Displacement is not negative. Displacement we can because it's only a distance, so it will be only positive over here. So 1 plus 1 equals to, so here we have alpha by 2, so half alpha by 2 we get as alpha by 4, so alpha equals to 2 into 4, that is equals to 8. So in this case answer is 8. Now if you check any of the solutions which is given online, they barely explain why this is negative, or they arbitrarily choose some of them negative, some of them positive, and they basically show that final answer is 8. They do not explain the correct concept behind such questions. That's why I request you to follow our channel if you have not yet subscribed or followed our channel, and also join the WhatsApp discussion group that is given in the description of this video. Now, last question of the day. Line charge of length a by 2 is kept at the center of an edge BC of cube A, B, C, D, E, F, G, H, having edge length A as shown in the figure. So this is the edge length A, does not matter. Okay. Okay. Only thing that matters is that the this is A by 2 and this is A. Okay. So here if the intensity of the line charge is lambda, if the intensity of the line charge is lambda coulomb per meter per unit length, then the total electric flux through the all the faces, so the cube will be, so you have to find the total electric flux through all the faces. Very interesting question. Now this A is not required, this A by 2 is required. Okay, don't get confused, they just tried to confuse you. We have solved a similar question where we have a similar cubic structure and the charge was kept at one of the corner. If you remember, same question here, instead of the corner they give you a line charge and the line is lying on the one of the edges. Okay, that is the same question as that. So what was the technique? If you remember, what was the technique that we used there? We used that instead of having one simple cube, okay, having like this, we said, okay, to solve it, what we have to do, we have to construct a larger cube, and for that we have constructed one cube over here, okay, one cube below, like we one cube in the backward side, one cube on this side, and we said that this can be considered to be total number of cubes 8, 1 2 3 4, and in the behind also 1 2 3 4. This is our corner, so behind also we have 4 cubes, here also we have 4 cubes, okay, and whatever is the net flux through this system, whatever is the net flux through this system, okay, flux through 1/8 of that, this is 1/8 of the entire cube system, okay. In that case we are calculating the net flux through one of the surfaces, only one of the surfaces, so in that case 1/8 into 1/6 also we had to done, but here we are trying to find the total electric flux, that means only 1/8 is sufficient, only 1/8 is sufficient. So basically what we have to do, we have to consider a Gaussian surface which is big enough, or of 8 cubes, okay, of 8 cubes, and what is the electric flux through that system, okay, and then we have to calculate the 1/8 of it. Now it is easy. What is the electric field? Electric field is basically 1/8 of the electric flux. Well, electric flux is Q by epsilon naught, right? Now I can show that how this comes, okay. You can you might think that, sir, I don't understand, this has to be some surfaces, okay, surface A, okay, you can do that, okay. That is possible. You will have to again multiply 1 2 3 4 8 into A's and all that, but finally the factor will come 1/8 of Q by epsilon naught, okay. That derivation I am not doing in this lecture. If you want, I can do that in one of the future lectures. So what is this A/2? A/2 is the charge length. What is the A/2 is the charge length, and what is the line charge density? Line charge density is lambda, so Q is basically lambda into A/2, that is A lambda by 2. So if you put that value, you will get 1/8 into A lambda by 2 epsilon naught, so it will be A lambda by 16 epsilon naught. Don't worry, this is the correct answer. So you just need to calculate the flask, and then you have to do 1/8 in case of cube related questions. This is the easiest way to solve such questions. In case of each surface, you have to divide it by 6. That's it, okay. So this is the electric flask. Actually it is not electric field, it is electric flask through all the surfaces, okay. This is we have sorry, there is my mistake. It is electric flask through all the surfaces of this cube. If it is located at any one of the edges, any one of the corners, nowhere, no matter where, if you are trying the total flask, it will be 1/8 of Q by epsilon naught. If it goes inside, then total flask will be Q by epsilon naught. That's simple, okay. In case of edges, you have to consider the edge effect. That's why you have to construct a bigger system, right? Also, you can see that the toppers of our previous year KCET, that is KCET 2025, they came here in our office, they met us, and we had a very beautiful picture along with us. All the teachers are here, and if you want to feature one of this, like one of the students, and definitely you have to subscribe to our channel, and this is the #1 YouTube channel for KCET for all of the students, right? And definitely I'll be back with the new chapter in our next class. Till then, bye.